Hello everyone, and welcome back to a, this is gonna be a rant video. So, I already said at the end of the overclocking session video for this card, the card, well, effectively died during the session. It wasn't a big problem though. I very quickly figured out what the problem is, and the problem is that this fuse right here blew up. And yeah. So I want to say something about that because I don't really get what Asus did here. They they made the PCB. They made those decisions. The same engineering department made those decisions, and they just don't make sense. So first I want to say, I'm not saying that the card overall is bad. It's a pretty good card overall. But I'm gonna be focusing on one little detail about the card in this video that I really don't like. So if it kinda sounds like I'm ripping on the card for being bad in general, I'm not. I'm just kinda pissed off that that one detail about it exists. So, before we get into that detail, let's first talk a little bit about the VRM setup of the card. So, every VRM needs a 12-volt input. And on this and pretty much every other graphics card, we have three 12-volt inputs, which you can easily see because every input does have a fuse on it on this card. So we have the PCI Express slot, which provides 12-volt. We have a 6-pin and an 8-pin. Those are the three sources of 12-volt power that we have. And usually, well, I think always they're kept separate on the card because you don't want to overdraw one of the sources. So you build your power planes in such a way that only things are connected to the inputs that draw the appropriate amount of power. If you connected just everything together, then each input would always handle 33% of the needed current, but an 8-pin can handle a lot more than the PCI Express slot. So yeah, you would overdraw the PCI Express slot at some point, or maybe even the 6-pin at some point. So that's why the power planes are kept separate. So anyway, the setup is pretty simple because you can somewhat easily see the power planes on this PCB. Because we have discrete MOSFETs, you just need to look at the high-side MOSFET and see what power plane it is connected to. So, the two memory VRM phases right here, which you can kind of easily see because the inductors are a bit taller, those are from the PCI Express slot. So the PCI Express slot does come through here. It goes through this input inductor, and then you can quite easily see how then this power plane's feeding these both of these high-side MOSFETs. So both of our memory phases are coming off the PCI Express slot. Then on our 8-pin, you can easily see the power plane goes here, through this inductor, then here, there's a split in the power plane, and it goes down to these three high-side MOSFETs. So that's where our 8-pin goes, to the lower half of the VCore VRM. And now you probably figured out what the problem is. Because our 6-pin, which goes through this inductor, goes right here, through here. It powers this high-side MOSFET, and then there's a little jumper here, because this phase, the fourth phase from the top, is configurable. You can configure it to run either of the 6-pin or the 8-pin, depending on which one of the pads you short. Now here it is connected to the 6-pin, so the 6-pin power also goes into phase number 4. So here we have a setup where the 8-pin is powering 3 VCore phases, and the 6-pin is powering 3 VCore phases. That's the problem. That's my main problem. And the problem is not that the 6-pin itself can't handle the kind of power that the 8-pin can. PCI Express power plug spec is very conservative. Like, the spec is 75 watts for this and 150 for this. Like, the difference is literally one ground pin, I think. Yeah, so like the 6-pin has, I think... Actually, I'm not sure. It might be 3... I am actually not sure. It might be one extra 12-volt. But like there's only one extra pin in an 8-pin that actually handles power because the other one they had is a sense pin. So the 6-pin already has 1 sense pin, the 8-pin has 2 sense pins, and then the others are either ground to 12 volt. I'm not entirely sure what the split is. But yeah, so the connector itself can handle that no problem. No, the main problem is the fuse, because Asus used the exact same fuses for everything. They are all 12 amp fuses, as you can see. 12 amps. Everything is 12 amps. So, the main problem you're gonna have here is because the 6-pin and the 8-pin both power the exact same thing. They both power 3 V-core phases. You're gonna max out that 12 amp fuse when the two 12 amp fuses in parallel on the 8-pin are only half maxed out. That's exactly what happened. So, yeah, because half of the V-core power draw always goes through the 6-pin and always goes through this 12 amp fuse, we can draw a maximum amount of 24 amps before this fuse blows up. That makes, at 12 volts, I think it's 288 watts total that we can draw from, like, through the V-core VRM on the 12 volt side before the weakest link, which is this fuse, blows up. It's not a whole lot, actually. I was thinking I was drawing much more power than that. And maybe there's a thing with, like, yeah, it's technically 12 volt spec, but you kind of actually have to draw like 15 amps for it to blow up. That could be a thing, but for the purposes of this video, I'm gonna assume it's 12 amps exactly, and then it blows up. So, yeah, that's not a whole lot. And you see, that problem of you can only ever use half the current that the 8-pin is fused for, like, I mean, the spec for an 8-pin is quite literally twice a 6-pin. So, yeah, it is per spec able to handle twice as much power, so that twice as much fuse makes sense here. But they chose to do an even split for the V-core VRM. I have no idea why. Because, here's the thing. Instead of shorting this pad, they could have just shorted this pad. So that the 8-pin powers 4 phases, and the 6-pin powers only the 2 phases. You know what happens then? Then the 8-pin handles twice as much power as the 6-pin, which lines up perfectly for both the PCI Express power spec and the fuses they put on the board. Wouldn't that be neat? And because of that, because then instead of half the power, only a third of the power goes through this fuse, you can't draw 24 amps max, you can do 36 amps max, which translates to, I think, 432 watts in total. So yeah, that's over 100 extra watts that you can draw through the VRM by literally just moving this shorted pad over here. Why didn't they do that? Like, literally, why Asus? Why? You made such a good card, and then you put this one thing in the wrong place. Why? And it's not like this happens to be like an engineering sample card or whatever. No, I checked. Like, Buildzoid's card has it, the card that Tech Power Up got for their review has it. All of the 570 direct CO2s have this pad shorted, and not this one. It doesn't make sense. They literally only have to move that here. Then the VRM can do so much more. Like, you don't even have to, oh, just add a second fuse, or oh, just replace the 6-pin with an 8-pin. No, you don't even have to do that. Just short this pad and don't short that one. That's everything they have to do. Why? That's just, like, why? Why did they do that? I literally not get. I think I'm just gonna do that. Yeah, I'm just gonna remove the solder from that and short that pad. And then, well, I don't have a replacement fuse, so I'm gonna have to bridge that one. I'm sorry. I'm just kind of baffled. Like, how did that get approved by the Asus engineering department? Like, okay, well, now I think about it, Asus engineering department approved a lot of very sketchy VRM decisions. But none of them was as easy to fix as this one. I'm just like, why? The only reason why they would do that I can think of, is that Asus doesn't actually believe that the VRM can handle 36 amps. That this is actually kind of their way of admitting, yeah, this VRM should have been an 8-phase, or should have had twice as many high sides, just like the 580 does. Because I can't really think of any other reason to do that. Like, I mean, the VRM was getting really, really, really hot. On the 580, on air maybe it gets hot, but like sub-zero or on water, if you have good airflow with the VRM heatsink, that's the exact same VRM heatsink that you have on the 580. The VRM, like, gets warm. This one was getting very, very, very hot. So, while it is still a pretty good VRM, a 570 isn't that far away from a 580, and they remove 2 phases and half the high side MOSFETs. So, yeah, this VRM isn't, like, compared to what kind of core it's powering, it's not as good of a fit as the 580 VRM. It's still a very good VRM though. Like, the reference 570 comes with a 4-phase and worse MOSFETs than this does. So it's still miles better than a reference card. So I'm like, is that the reason? Is that actually just Asus's way of admitting that their V-Core VRM can't handle 432 watts or 36 amps? Is that the reason? Because I can't think of anything else. Like, yeah, I can't think of any other reason why they would short this pad and not that. Because, like, the PCB isn't made for 2 8-pins. Like, sometimes you have it that, like, 2 8-pins were originally meant for the design, but then they moved, like, they returned 1 8-pin into a 6-pin. And then you can, like, see, oh, there's a 6-pin, but there's, like, 2 extra pads here that are just unused. That's not the case here. This PCB is meant for 6 plus 8-pin. So it's not like, oh, they turned this into a 6-pin and then forgot to move this one. No, they didn't. This was always meant to be a 6-pin, unless they did some very extensive modification of like this area, because they also would have had twice as many fuses and whatnot. So I'm just like, why? Why does this exist? Like, less than a centimeter. You just move that bit of solder, less than a centimeter, and your VRM becomes like over 100 watts more capable. Like 288 to 432, if I remember correctly, is what I calculated it to be. That's almost 150 watts. No, that's like exactly 140, isn't it? Still though. That's closer to 150 than 100. Like, why? Why? Why did you do this? Asus, why? This is kind of like this is kind of like the thing why I don't want to put Asus components in my daily system. Okay, the main reason why I don't put Asus components in my daily system is because they're really, really expensive, and they have no business being that expensive. But another part of why I don't like putting Asus components anywhere near like my daily system, which is meant to like be reliable and not be fast, is just kind of, they keep making decisions like that sometimes, and yeah, I would just like to have hardware that doesn't have engineering errors like this inside of them. So yeah, that's just kind of what I wanted to say. The video is not really supposed to be any longer than this. I just wanted to, like, yeah. I just kind of wanted to rant about this, because it's so easy to fix. They literally made the work to implement a fix for themselves, and then they just decided to not use it. That's just kind of the thing. Like, usually when you see PCBs that have, like, engineering mistakes, so to say, like, you could have made this a lot better, or like, you should have made this a lot better, you usually go like, oh, they used the wrong MOSFETs, or like, they should have used more phases, or whatever. This one literally boils down to a little bit of solder being in the wrong place. So, yeah, yeah. That's it. So, rant over. I think I've ranted enough. So, please, Aces, no more stuff like this. I know you're not gonna stop, but yeah. Anyway, that's the rant. Goodbye.